Good day, geometry. Quiet, please. We're going to be taking a number of notes today on a bunch of different geometric relationships that you're going to be able to use as evidence for your deductive reasoning events when we start to do proofs. Okay? When you start to do geometric proofs and using that deductive reasoning based on evidence, postulates, theorems, definitions, those are the things that you can use. Like I said, these do not have very fancy names for them. I don't have what each one is memorized myself, so I'm going to turn the textbook for my assistance. If you want this from your textbook, it's on page 96, but we're just going to put everything that's on there on this page now anyway. So postulate 5 says that through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. Through any 2 points, there exists exactly one line. Where we've seen this before was in graphing equations. Think back to slope-intercept form. How many points did we need to graph a line on the coordinate plane? 2. We need the y-intercept and the slope, right? Or the x-intercept, that would work also, right? But when we graphed in slope-intercept form, we needed the y-intercept and we needed the slope because that gave us 2 points we could connect with a line, and that's all we needed. Because through any 2 points, it was because of postulate 5 that we knew that we only needed those 2 points. Now, I didn't tell you that, right? Because you weren't ready for it. It was enough just to graph, but that's where that comes from there. Postulate 6. A line contains at least 2 points. A line contains at least 2 points. Okay, it's kind of the not quite the converse of postulate 5, but it's very similar to it, right? If you know you have a line, you know that you have 2 points on it, such as the y-intercept and the x-intercept, or the y-intercept and some of the points, some slope, some of that makes it work. Okay, warning for you. Catherine, you need to know the relationships so that if I ask you how many points do you need to make a line, you need to know the answers too. Okay, but I'm not going to say what is postulate 5, and you have to regurgitate that. So you need to know the relationships, but not by the number of their postulate. Okay, so again, if I ask you how many points are there in a line, you'll need to tell me at least 2. Right? You need to know the relationships, but you don't have to tell me at least 2 because of postulate 6, right? I'd rather you, if I ask you how many points are in a line, your answer wouldn't be postulate 6. Your answer would be at least 2 because of postulate 6, but you don't have to know that it's because of postulate 6. Okay? Kylie. I don't know. There are things that are kind of more used algebraically than geometrically. Second warning for you, Vince. You won't use these too often in a formal proof because they don't have fancy names, but they are definitions, they are relationships that will help you with the fancy names. Right now, that probably doesn't make a lot of sense. Just like last year, if I told you that we only need the y-intercept and the slope because of postulate 5, it wouldn't make a lot of sense. So just trust me on it for now. But it's because they're not used geometrically, more algebraically. Anthony.
Just so I'm less confused, what does postulate mean?
It is basically a mathematical relationship. I'll leave it at that. Yeah. Damien.
What do you mean by mathematical relationship?
Like vertical angles being congruent, that is a mathematical relationship. A triangle having 3 sides, that is a mathematical relationship. It is something that can be concluded, right, having to do with math. Okay. Postulate 7. If 2 lines intersect And I'll also change that to be my segment ray line abbreviation. So if two segments, rays, or lines intersect, when I write SRL, it stands for segment ray line. We've talked about that before. So if two segments, rays, or lines intersect, they intersect at one point. Okay? If two segments, rays, or lines intersect, they intersect at one point. Again, if two segments, rays, lines intersect, they intersect at one point. Basically saying that you can't have two lines intersect in two different places. Why does that make perfect sense based on what you know about lines? Kylie? Right, they don't curve. Okay. If you think back to Oxenoy, systems of equations, right, last year, we started with graphing two equations, and where they intersected on the coordinate plane, we knew that was the solution for x and y because we knew that lines can only intersect in one place. That's the one spot where the x value and the y value are the same. That is because of postulate 7, right? Again, it's another mathematical relationship. Postulate 8, through any three non-collinear points, I know, but I have to stand here to write it, calm down. Through any three non-collinear points, what was that? Body? Wow. There exists exactly one plane. Okay? Through any three non-collinear points, there exists exactly one plane. We talked about this when we first defined a plane back in CO1. We said it had to contain at least three non-collinear points. An example, if you have 3 points in a triangular shape, right, we cannot connect them with a single line because the line would have to bend, which it can't. So there exists a plane around those three non-collinear points. So this one we've already kind of talked about before, but coming back. Postulate 9 is kind of the converse of postulate 8, but it says that a plane contains at least three non-collinear points. A plane contains at least three non-collinear points. Non-collinear, not on a line. If 3 points are collinear, then they make a line, right? Because a line has at least 2 points in it. 3 can make a line. But if they're non-collinear, can't make a line, then they exist in a plane. I'm going to move this up now so I can write a little bit easier. You can read a little bit easier. So if you need any more definitions, jot them down quick. Or refer to the video tonight. And don't forget to like and subscribe. I hope so. Otherwise, what am I even doing here? Why do I pay my $12.95 a year to be able to record? What's that? These are all key points. These can go on to help you. Yes. Okay. Sounds like we're done. Okay. Postulate number 10 says if 2 points lie in a plane, then the line containing them is also in the plane. If 2 points lie in a plane, the line containing them is also in the plane. Yes. Meaning that if you've got a plane, right, so you got at least 3 points in here, you can connect to those points with a line, right, because the line just needs 2 points to make it. So because those two original points were in the plane, the line connecting them is also in the plane. Okay, it's on the same level as whatever the plane is. Yes?
Would it also work if it was like a segment or a ray?
Yes, yes. You can, if you want to put segment ray line, that would work as well. Bryn?
For postulate 8, could there be more than 3 non-linear points?
Yes. Yep, more than 3. Okay, and then postulate 11 says that if two planes intersect, there you go, intersect, then their intersection is a line. If two planes intersect, then their intersection is a line. An example of that would be your three-dimensional volume figures on your math packets, right? Think of a cube. A cube has like a plane that's a side, like the height, and a plane that's the top. Where they intersect creates an edge of the cube, right? It's the side length of the cube. So in three-dimensional shapes, all those flat surfaces, right, that make up the shape, where they intersect, they create an edge of the shape or a line of the shape. Think back to algebra. We already kind of answered this. Which concepts were we using postulate 5 and 7? We used them in graphing. Okay, graphing, slope, intercept form. And so your homework now. Oh, is there a word today, by the way? There is?
You said it was word.
You kidding me?
No. He said it was too easy.
Thanks, Boyle. Okay. So
Mr. Boyle just picks religious. Are you freaking kidding me right now? It's so stupid.
wasn't one of them happy? That's not a religious. I mean, so there is a word, and apparently it's religious today. So that gives me a hint. So I'm gonna kind of. All right, 3, 2, 1. You are quiet. Damien, second warning for you. I count it down. Arlene. Oh, it's kind of are. They don't have to be. It's just kind of the way that they are. I don't know. I don't know the reason behind it. It's just what it is. Oh. But what we're going to use these postulates for is to now, given a diagram such as this plane here, okay, and then all the stuff in it, what conclusions can we make? The first one, true or false, all points shown are coplanar. Yes, right? Coplanar would mean in the same plane. All those points do lie within the same plane. G, F, and E are collinear. They could be, right? But is there deductive reasoning? Is there evidence? Is there factual information they are collinear? No. And why can't we definitively conclude they are collinear?
Because they look like it, but one of them could be a little bit off.
They look like it. One of them might be a little bit off. Maybe it's not drawn to scale. There's no line connecting them. If there was a line connecting them, then yes, we could conclude that. But because there's no line connecting them, we cannot conclude that they are collinear. Angles AHB and BHD are a linear pair. So here's AHB. Remember, angles can be labeled with letters. The vertex is in the center. So from A to H to B, that's angle AHB. BHD goes from B to H and over to D. Are those two angles a linear pair? How do you know that? Arlene?
Because a line is 180 degrees.
Yes, they make a line, right? They together form line AD. That's what a linear pair is, a pair of angles that makes a line. So yes, they are. Okay? So your homework is going to go through the rest of these and label yay or nay. Can you conclude that statement based on what you see in the diagram? In addition to that, because that's not very much for you to do, I would also like you to do 39. Page 101, number 39. That's all. Page 101, 39. That's all you gotta do for homework, including this. So this and page 101, number 39. That's how you math.
Don't forget to like and subscribe.